More captivating than the rearward, in any case, a late disclosure has caused a basic part between experts as they look at the information. Now, the intensely expected portrayal of clarity has appeared, as famous astrophysicist Neil deGrasse Tyson uncovers the amazing divulgences in space. Join us as we explore how Explorer 1 perceived 500 dim objects going through space and discover Tyson's thoughts on this bewildering revelation. On June 30, 1908, a stony space rock crashed into Earth, striking a city in Siberia, Russia. The strong impact of this event caused the night out of around 2,000 square kilometers. The effect of this event resonated worldwide, causing a by-and-large shockwave. Research following this event induced the publication of The Authentic Joining Between Cosmology and the Military by Neil deGrasse Tyson, where he highlighted the mix of reasonable examination and public safety, supporting for extended interest in space assessment to shield our planet. This noteworthy work changed public attention to the significance of room assessment. In a befuddling turn of events, NASA's space gadget Explorer 1 has just identified 500 dim objects passing by in space, leaving examiners puzzled. Neil deGrasse Tyson, the remarkably notable astrophysicist, has emerged again to give genuinely critical clarity. However, as examiners dove into the secret of these 500 unidentified objects, they inadvertently found a staggering discovery about Explorer 1 itself. Before we explore that discovery, we must first acclimate ourselves with the Explorer 1 rocket. Explorer 1, the rocket currently under examination, has already voyaged an astounding 145 billion miles from Earth. The speed at which the rocket goes through space is truly bewildering, covering a distance roughly 3.6 times the space between the Earth and the Sun every year. However, there's another side to the interstellar test. Beyond its speed, future, and distance from Earth, Explorer 1 has sent various earth-shattering discoveries to us, like the ongoing identification of 500 dim objects in space. These are peculiar, glorious things that we've never seen or perceived before. We'll get into that big uncover in just a minute. By now, there's a question that is probably at the very front of your mind. How could a rocket, launched way back in 1958, still be working and conveying such critical information? Well, the response lies in the astounding preparation and instinct that went into Explorer 1's design. One of the key extraordinary features that have expanded its life expectancy is its double-access computer systems. Each Explorer rocket, including Explorer 1, was equipped with two sets of command computer subsystems: the Flight Data Subsystems, FDS, and the Attitude Control and Explanation Control Subsystems, AACS. This distinct redundancy acts as a significant safeguard, allowing for predictable progress between systems and the capacity to replace faulty computer parts, thereby extending their future. The computer systems on board Explorer 1 and its twin Explorer 2 were designed as a distributed structure with three double redundancy arrangements of computers. This redundancy ensured that regardless of whether one system failed, the other could take over, preventing critical failures. To utilize limited power sources, the Explorer instruments depended on planned logic. This means the computer systems were designed with optimized circuits to ensure they could work within the power budgets and time limits during the rocket's mission. Yet power management is crucial in maintaining Explorer 1's functional integrity. The rocket's distance from the Sun, where it can harness solar energy, presents a significant challenge to maximizing power efficiency. Engineers needed to think of innovative ways to conserve and improve power use. The power management strategy used by this critical spacecraft is genuinely remarkable. One essential part of power management involves explicitly shutting down unnecessary systems. Specialists carefully evaluate which parts or subsystems are not essential for the primary mission goals. For example, radiators related to certain scientific instruments have been deactivated. These radiators were initially designed to maintain the instruments at specific temperatures for optimal performance. By turning them off, power consumption is greatly reduced, thus extending the spacecraft's overall life. This decision to shut down unnecessary systems is not taken lightly. It requires careful assessment of the trade-offs between power conservation and the scientific objectives of the mission. Engineers work closely with scientists to ensure that deactivating specific systems doesn't compromise the quality or availability of scientific data. The goal is to find a balance that maximizes power efficiency while maintaining essential functionality. However, that's not all. Explorer 1's power management systems also adapt to the changing conditions of its environment. As the spacecraft ventures farther from the Sun, the available solar energy decreases. To compensate for this, Explorer 1 adjusts its power usage accordingly. This versatile approach ensures that available power resources are efficiently allocated to support essential operations and data transmission. Over the years, there have been continuous technical advancements and improvements in power management strategies, allowing engineers to refine and further develop the power systems of the Explorer missions. These improvements include more efficient power distribution, improved battery charging methods, and advancements in power regulation and control. Thanks to these meticulous power management systems, engineers have successfully extended Explorer 1's operational life, enabling it to continue its scientific journey through the universe. Considering that the rocket was initially expected to last only 5 years, the fact that it's still transmitting data nearly 50 years later is extraordinary. It highlights the commitment and skill of the researchers and engineers who have worked tirelessly to keep Explorer 1 functional. However, despite this careful planning and design, the depths of deep space remain unpredictable. Stay tuned, because a critical revelation is coming. What did Explorer 1 find? What did Explorer 1 track down that stunned experts? While there are some broad theories for what Explorer 1 might have initially encountered, meteoroids, space rocks, and space debris, there is always the potential for astonishing discoveries. One such astonishing turn in the Explorer 1 mission was the spacecraft's detection of 500 puzzling objects. This discovery caused quite a stir and raised significant concerns among the scientists handling the mission. These strange signals and anomalies in the data came as a complete surprise. Explorer 1 began sending telemetry data back to Earth, but the readings were odd, and there was no clear explanation for what was happening. The experts marked this anomaly as a mystery. However, despite some erroneous transmissions, Explorer 1 continued to respond to orders from mission control, albeit with a slight delay in communication. This was perplexing, and it became a mystery. What was especially confounding about this inconsistency was that it didn't trigger Explorer 1's built-in fault protection systems. These systems are designed to activate when abnormalities are detected, setting the spacecraft into a test mode that allows engineers to investigate and analyze the issue. In this case, however, Explorer 1 continued its operations without entering test mode, adding to the mystery. After thorough evaluation, the anomaly was traced back to the Attitude and Control Subsystem, AACS. The AACS plays a crucial role in organizing the spacecraft and controlling its movements. With a 22-minute delay for a radio transmission to travel one way between Earth and Explorer 1, this significant time delay presents challenges for continuous communication and command execution. Despite these difficulties, the mission team successfully implemented the fix-to-course telemetry data to the onboard computer. However, the process was not without its complications. Given the vast distance between Earth and Explorer 1, even essential communication commands took time to reach the spacecraft, and the subsequent response had a significant delay. Nonetheless, the fix was eventually implemented, and telemetry data began flowing through the proper channels, providing clearer and more accurate information about the space environment surrounding Explorer 1. With the anomaly resolved, analysts could now focus on analyzing the data gathered by the spacecraft. As experts delved into the telemetry data, they made an astounding discovery. Among the 500 unidentified objects identified by Explorer 1, there was a subset of items showing highly unusual characteristics. These items exhibited erratic movements, irregular shapes, and unusual spectral signatures, unlike any known galactic anomalies. Initially dismissed as instrumentation errors or noise, further investigation uncovered consistent patterns in the behavior of these strange objects. They appeared to defy conventional explanations and challenged existing models of celestial mechanics. Researchers were puzzled by the nature and origin of these mysterious objects. The discovery of these enigmatic objects sparked intense discussion and speculation within mainstream science. Some scientists proposed bold theories, including extraterrestrial intelligence or advanced propulsion systems, while others maintained a more skeptical position, advocating for more conventional explanations. In light of these discoveries, Neil deGrasse Tyson weighed in on the significance of Explorer 1's findings. In a series of interviews and public statements, Tyson emphasized the importance of maintaining scientific rigor and mindfulness when investigating the unknown. He cautioned against jumping to premature conclusions and encouraged researchers to conduct thorough investigations before drawing definitive conclusions. Tyson's measured response to the revelation of the puzzling objects helped temper sensationalism and promoted a more cautious approach to scientific inquiry. He stressed the need for continued observation, data collection, and analysis to unravel the true nature of these perplexing anomalies. Soon after the initial revelation, scientists worldwide ramped up efforts to study the strange objects identified by Explorer 1. Observatories, space telescopes, and ground-based instruments were engaged in monitoring the regions of space where the anomalies had been detected, gathering additional data to complement the spacecraft's observations. Step by step, a clearer picture began to emerge. As scientists pieced together the riddle of the mysterious objects through careful examination and collaborative research efforts, they uncovered clues about the objects' origins and behaviors. While many questions remain unanswered, each new discovery brought researchers closer to understanding the nature of these galactic mysteries. As the investigation into the mysterious objects detected by Explorer 1 continues, scientists remain focused on unraveling the secrets of the universe. Their dedication to exploration, discovery, and understanding serves as a testament to the human spirit of curiosity and inquiry. In the end, the discovery of 500 unidentified objects by Explorer 1 represents a milestone in the history of space exploration. It has challenged our understanding of the universe and opened new avenues for scientific inquiry. By carefully studying these mysterious anomalies, researchers hope to uncover the secrets of the universe and expand our knowledge of its complexity and diversity. As the investigation into the 500 mysterious objects discovered by Explorer 1 continued, the scientific community faced a range of challenges in trying to interpret the data. The sheer number of unexplained objects detected raised several fundamental questions about the nature of space itself. Was this a one-time anomaly? Or was there something far more significant at play in the vast, uncharted regions of space? For scientists, these questions open the door to deeper explorations of cosmic phenomena and the potential for new scientific breakthroughs. One of the primary focuses of the research was determining the precise origin of the 500 objects. Were they naturally occurring phenomena, such as comets or fragments of asteroids, or could they be the result of artificial sources? The data collected by Explorer 1 showed characteristics that didn't match known celestial bodies. Some objects exhibited an unnatural consistency in their movement, which defied the laws of gravitation, while others appeared to shimmer or display unique emissions that resembled no known forms of cosmic radiation. To shed light on these findings, collaborations were forged across various scientific disciplines. Astrophysicists, engineers, and data analysts worked together to scrutinize the telemetry from Explorer 1, looking for patterns and signatures that might offer an explanation. Some suggested that the objects could be related to dark matter or dark energy, phenomena that are still poorly understood but believed to make up a large portion of the universe. Others speculated that the objects could be connected to exotic space phenomena, such as wormholes or anomalies in the fabric of space-time that had never been observed before. In an attempt to clarify these issues, various space agencies and observatories across the globe stepped up their efforts to monitor the regions in space where Explorer 1 had detected the mysterious objects. Ground-based telescopes and deep space probes were deployed to capture more detailed images and data from the same areas of space. Additionally, many researchers turned to advanced simulations, using supercomputers to model how such objects could behave and interact within our universe. These models helped experts to hypothesize that the objects could be influenced by the gravitational pull of distant stars or black holes, offering a potential link to previously unexamined aspects of space. The involvement of international space agencies also brought about an increased interest in the possibility of extraterrestrial life. As scientists delved deeper into the anomalies, some experts began to explore the potential for intelligent extraterrestrial life forms behind the objects. While some dismissed this idea as speculative, the thought that these objects could be related to alien civilizations sparked debates in the scientific community. The The idea of extraterrestrial intelligence has been a topic of fascination for centuries, and the discovery of such objects raised new possibilities for its existence. Meanwhile, Neil deGrasse Tyson continued to advocate for a measured and careful approach to the situation. He urged scientists and the public not to jump to conclusions about the nature of these objects, emphasizing that while the discovery was extraordinary, it was important to remember the uncertainty inherent in space exploration. According to Tyson, it was crucial for the scientific community to maintain its commitment to empirical evidence and to avoid sensationalizing discoveries that were not yet fully understood. He stressed that the mystery surrounding these 500 objects was a golden opportunity for scientific inquiry, but only if approached with rigor and patience. Tyson also highlighted the importance of maintaining public interest in space exploration, emphasizing the role that curiosity and wonder played in advancing scientific knowledge. He believed that the public's fascination with the mystery of space was crucial to inspiring the next generation of scientists, engineers, and innovators. In interviews and lectures, he spoke passionately about the need for continued investment in space exploration, pointing out that the universe, with all its mysteries, remained an untapped frontier for human understanding. As more data flowed in and more research was conducted, the enigmatic objects detected by Explorer 1 gradually began to yield more clues. Some were found to have distinct spectral lines that indicated unusual chemical compositions, while others exhibited behaviors that suggested they might be moving at speeds faster than light. While much of the data remained inconclusive, the sheer scope of the discovery was enough to spark a renewed sense of excitement within the scientific community. Ultimately, the ongoing investigation into the 500 unidentified objects detected by Explorer 1 serves as a testament to the potential for discovery in the universe. As researchers continue to analyze the data, it is clear that this finding may be just the beginning of a new era in space exploration, one that could dramatically alter our understanding of the cosmos and our place within it. Through careful study and collaboration, scientists hope to unlock the secrets of these mysterious objects and, in doing so, open the door to even greater discoveries in the future.